All right, ladies and gents, I want to go ahead and make a video for you guys to review tonight and hopefully help you out on your test. You normally don't watch these videos, so hopefully I'm not wasting my time out here. But let's get to it. So we're talking about arithmetic sequences. I'm probably not going to run through every single problem on this grid, but I'll take it one step at a time. All right, so looking at number one here, it's saying to write the rule for the following sequence. All right, well, in this case, we already know that it's an arithmetic sequence because it's indicated on here. But how could we find out if it's an arithmetic sequence? Well, you take any number in the sequence and you subtract the number that comes before it. And so if we had 9, let me get my marker out. If we had 9 minus 2, that would be equal to 7. And so that would mean we would have a common difference equal to 7. And so if we look down here at our explicit formula, then we can pretty much just write everything out from here. And so here, a sub 1 is telling us that that is our first term in the sequence, which in this case is -5. So we can write that. -5 plus d, in this case, d we see is 7. And then everything else is just provided for you. So you have -5 plus 7 multiplied by the quantity of n minus 1. And so let's do that math. You got 7 times n, which is 7n, and then you got 7 times -1, which is -7. You bring down your -5, then you combine like terms, and in that case it's going to end up being your final answer is going to be 7n minus 12. And so our rule, I'm just going to go ahead and write it down here under number 2. Our rule is a sub n is equal to 7n minus 12. Okay, so number 2 is asking us to find the 10th term. So if we're going to find the 10th term, that means we're going to have to plug in 10 for n. And so that is a sub 10 is equal to 7 multiplied by 10 minus 12. And if we punch that into our trusty calculator, we'll end up with a sub 10 is equal to 58. Boom, we're done. I mean, it really is that simple if you allow it to be. And I tell you what, you got the teacher at home with you. You can pause, you can rewind, you can watch it again over and over until you just eventually get it, right? So let's look at number 3. All right, again, it's asking for you to write the rule. So it's pretty much asking for the formula after we've identified the first term and then the common difference. Again, we know that we're dealing with arithmetic sequences. And so how do we find our first term? Well, guess what? It's right there. So let's go ahead and write that. A sub 1 is equal to -15. How do we find the common difference? Common difference is any term subtracted by the term in front of it. So we got -13 minus a -15 is equal to, again, put in your calculator, but you'll get 2. And so we know our common difference is 2. So now we write out our formula. So we have a sub n is equal to our first term, right? -15. And then our common difference is a +2. And then remember, multiplied by n minus 1. Then we have to go ahead and distribute out. 2 times n is 2n, and then 2 times a negative 1 is minus 2. What's remaining up there still is the negative 15. If you combine like terms, in this case, it's these two. It's a negative 15 and a negative 2, which is equal to negative 17. And what we have left is our 2n. So we throw our a sub n in front of it, and we have our formula, or our rule rather. So to recap, we need, when we're looking at the formula, this is a sub 1, which is the first term, so in this would be a negative 5. Then we have our common difference. How do we find that? We take any term subtracted by the term in front of it. We did that, 13 minus negative 15, that gave us 2, and that left us with a common difference of 2. Now we just take our formula, a sub 1. In this case, we plugged in our negative 15. We found our common difference. We put that in, and then we just multiplied everything out and combined like terms, and that's what led us to our rule. So now on number 4, it's saying 7 is basically the blank term of the sequence. And so now we have to figure out what term is 7. And so you may ask, how do we do that? Well, we have to set our rule equal to 7. And 2n minus 17. And now, what are we solving for? We're solving for n. How do we do that? Get everything away from n. So, plus 17. Whatever you do on one side has to be done on the other. Plus 17. That cancels out. We're left with 2n is equal to 24. Again, if you're not good with doing this math in your head, calculator is your friend. So how do we get this 2 off of the n there? That's multiplication. Opposite of that is division. And that leads us to n is equal to 12. All done. If you didn't get that, go back, watch it, follow it through step by step, and again, keep watching it until you get it. Ask your parents for help. So let's move along to number 5. All right, so number 5, we're looking at geometric sequences. So that's different. All right, so it says multiplying or dividing. And so as compared to having a common difference of d, you're going to have a common ratio of r. And so finding r is very similar to finding d, except for using subtraction, we're going to be using division. And so you take any term, in this case, we're going to let's just use 6 and 3. So you take any term divided by the previous term. And so 6 divided by, thing glitched on me there. 6 divided by 3 is equal to 2. So up here we'll write, we have a common ratio, our r, equal to 2. And guys, if you can do that, it's easy money from there. We found r, and if we did the same thing, 12 divided by 6 is 2. So if we do it twice, we see that r is, the common ratio is 2 twice. We feel pretty good about our sequence then. And so if you look down here at our formula, all you need is r and then a sub 1. We know that that is just the first number in the sequence, and so we'll write it out here to the side next to r. A sub 1 is 3 because it's provided for us. The sequence starts with 3. All right, and so now we're just plugging in our information. So we have A sub n is equal to our first term, which is 3, our common ratio, which is 2, and then again, n minus 1 up in the exponent. And that's that, guys. If you don't get it, you already know what I'm going to say. Watch it back. So looking at number 6, I know it probably seems like I'm in a rush, but I got to be, because I got to get this uploaded in time for you guys. So it's number 6 is saying find the 15th term. How do you find the 15th term? Well, we already have our rule, and so in order to find the 15th term, all we have to do is plug in 15 for n. So shall we do that? So we want A sub 15 is equal to 3, common ratio of 2, 15 in place of n, that, and then punch that guy right into your calculator. And what is that going to give you? That's going to give you A sub 15 is equal to 49152, 49,152. So what does that mean? That means we had our first term here, 3, 6, 12, 24, 48, and if we kept counting up to the 15th one, it would be 49,152. That's what that means. All right, so this is where, well, let's look at number 7. Because number 7, we see all these words and we start losing our mind, like oh, words, we don't want to do that. Okay, it's too easy to just give up. All right, so let's look back at our formula over here. We're looking for the first term, or this is the starting point. Common ratio is the common thing that's changing consistently throughout our sequence. And then we know n is just the term that we're looking for. So let's read. Hillgrove has 324 kids that show up to try out for baseball on the first day. Okay, well, how many kids showed up? 324. So clearly 324 kids is our starting value. Okay, and so we know based on our formula that A sub n is equal to the first term, or the starting value, which is 324. Let's continue reading. So it says, if a third get cut each day, write a sequence for the scenario. Well, what's the common ratio? It's providing us with the common ratio right there. It's telling us that a third is the common ratio, because that's how many are getting cut per day. And so we just plug that third in for R, since they're providing that for us. So that is 1/3, and then again n minus 1, and that's our rule, or that's our explicit formula. And so now that we have that, we can move along to number 8. Now it's asking us how many cuts will it take for there to be 12 kids remaining. So we have 12 we're wondering about. We have an n up here because we're looking for the 12th cut. So now we're just plugging in 12 for n. So we have A sub 12 is equal to 324 multiplied by 1/3 to 12 minus 1. And again, after you punch all that into your calculator, you should get 4. So that would be 4 cuts. Wait, actually, no. My bad, ladies and gentlemen. That is not correct. Let me erase that. Got ahead of myself. I have a key sitting next to me saying that the answer is 4, but I'm looking at that now and I realize, no, that's not going to be 4. We're not plugging in for 12. We want to know how many cuts, and so N represents cuts. So cancel all that I just said right there. See how easy it is to make a mistake, ladies and gentlemen, but we learn from these mistakes. So we want to know how many before we get to 12. And so 12, we have to set it equal to 12. So that's 324. And now it's 1/3 to n minus 1. So we could go through and we can talk about all this complicated math, but I don't even want to think down that path. And so I'm going to tell you how to use the calculator to solve this. You're going to type in to your table under edit function this part, not the 12. So you're going to put 324 multiplied by 1/3, and then in the calculator it's x, so x minus 1. And then in your table where y is equal to 12, you're just going to just find the x value that coincides with that. And then when you find that, you're going to discover that x is equal to 4. So again, the part that you're putting in the calculator is this part, and we should all know how to do that already because that's what we showed you guys. In the table, you're putting 324 multiplied by 1/3 to the n minus 1 power. Scroll down on your calculator until y is equal to 12, and that's going to tell you what x is equal to, and x is equal to 4. So moving right along, we're going down to number 9. God, I said I wasn't going to answer all these, and here I go. Number 9, which goes with solving exponential equations. Remember that the base must be the same before you can cross them out and eliminate them. Okay, then after that happens, you're going to set the exponents equal and just solve for x. So in this case, both our bases are 5, so we can get straight to it. We can cross out the 5s. That leaves us with 3x plus 1 equals x minus 9. We are solving for x, and so we can't have an x on each side, so let's start by getting x off of that side and bringing it over here. That cancels. Of course, I have to do it on the other side. That turns into 2x plus 1 equals negative 9. So, all right, pause for a second there. I kind of zoned out for a second. So, guys, I know how you feel. You're sitting there studying, zoning out. I'm out here zoning out, just making the study guide for you guys. All right, so we're on the same page, but study nonetheless. Okay, so looking at number 10, we have two bases here. The bases are not the same. 9 and 3, not the same. And so we have to make them the same. I told you before, you can take the bigger base and divide it by the smaller base. And so in this case, that is 9. Oh, go back to the pen. That is 9 divided by 3, which is equal to 3. Now remember, after you divide, if the answer that you get is bigger than either one of the bases, then you must again divide by what you divided by previously. So in this case, we divided by 3. If we didn't get a 3 and it was still bigger than one of our bases, we would have divided by 3 once again. But in this case, we don't have to do that because we got a 3. And so since this base here is already a 3, we're going to keep that the same, which means we're also going to keep the exponent the same. There's no change there because that's already our base. Now the 9, on the other hand, we switched that to 3, but we got to figure out how many times we have to multiply 3 by itself to get back to 9. I mean, if you don't know how to think that up, you can just start multiplying 3 by itself. So you put in your calculator 3 times 3. Okay, well, 3 times 3 is equal to 9. How many 3's did you enter in there to get to 9? That's 2 3's, 3 times 3. So that means we're going to end up raising that to the second power. You already had an x up there, so I always say put whatever you had up there in parentheses when you're adding something else up there before it. Now, so now we can cross out our bases, and that leaves us with x minus 8 is equal to 2 times x is 2x. And so we have x minus 8 is equal to 2x. So now we just start solving for x. So let's get rid of that x. Whatever you do on one side has to be done on the other. That leaves us with negative 8 is equal to x. And we're all done. You know what? I guess I'm already doing this, so I might as well just go ahead and do the rest, all right? So using the same strategy that I said before, we're looking at number 11 now, guys. We're down here. All right, our bases, we have an 8 and a 4. That is not the same, so now we know we're going to go into 8 divided by 4 is equal to 2. So I want to use a base of 2. So I'll write that. Now, how many times do we have to multiply 2 by itself in order to get to a 4? Well, 2 times 2 is 4. That's 2 2's, so that is a 2 up there. And then 3x is already up there. And then equal to another base of 2. So now we have to figure out how many times we have to multiply 2 by itself in order to get to an 8. And well, 2 times 2 times 2 is 8, so we put a 3 up there. Everything else that was up there goes inside the parentheses, so x plus 1. Now, we're able to cross out our bases and set everything else, set the exponents equal to each other. So first we have to distribute. So 2 times 3x is 6x, and then distribute this 3 in, that's 3x, and then distribute that to the 1 is a positive 3. And of course, now we're solving for x. So let's go ahead and start by subtracting 3x. Remember, we're trying to get x onto one side. That cancels. It leaves us with a 3x is equal. Oh, I'm on the bottom of my page, guys, so it's hard to write down here because it's wanting to pull up a different screen. So, how do I remedy that? I guess I'll write a little higher. My cosine is going to be a little weird, so 3x is equal to 3. So let's move up over here. So 3x is equal to 3. We want to get rid of this 3, so that's multiplication. We'll divide to get rid of it, and that leaves us with x is equal to 1. Moving along to number 12. All right, so again, we're looking at our bases. That's a 4, and then the base here is a negative 1/4. Okay, and so we want to have a base that matches. Both bases have to be the same on each side of the equal sign. And so we talked about this in class. We talked about negative exponents. So in this case, well, actually, let's say it like this. I told you guys to start, just look at the two things that we told you you're going to look for as the base. In this case, you have the 4 over there, and then you have the bottom of the fraction. And so how do you take that off the bottom of the fraction and match it with the 4 that's out here? Well, we told you that 1/4 is the same thing as 4 to the negative 1/2 power. And so in order to take that 4 out and make it a base of 4, we have to bring it out. We're going backwards. So we have to bring it out and make it a 4 to the negative 1/2 power. I mean, I felt like this is the biggest area that you guys struggled on. So it matches the 4 out here. And then, so we're just keeping everything consistent over here. 4x plus 8 in the exponent. And then it's literally just solving from there. So we can cross out our base. That leaves us with 4x plus 8 is equal to negative 1. Ooh, and as I'm writing this, I'm realizing that we just only put our negative 1 down here. We can't do that. So let's look back for a second, because we never brought down our x minus 18. So let's do that now. So just to recap, don't want to lose you guys. All right, so we had a base of 4 here. We brought that down. All this stayed the same to the exponent of 4x plus 8 is equal to 4 to the negative first power, but we didn't bring down x minus 18, so you gotta do that. So x minus 18. And so now we have to distribute, going back to our math here, get a different color ink, distribute negative 1 to x, that becomes negative 1x, and then distribute that becomes a positive 18. And so now we can solve. Guys, it's very easy to make mistakes, especially if you're trying to go fast. And I'm trying to go fast, and so thus we've already witnessed me making 2 mistakes just in this video alone. All right, so slow down. If the teacher can make a mistake going fast, you certainly can make a mistake. Move carefully, study carefully, and especially move carefully when you're taking your test tomorrow. All right, so now we have to solve for x. So let's add an x here. Again, whatever you do on one side has to be done on the other. Guys, I'm running out of room, so now I'm going to move this all the way up here. So after we do that, we're going to be left with 3x plus 8 is equal to, it's an ugly 18. And notice, guys, I just subtracted an x, but I should have added 1. So that is a 5x. All right, so now, again, we keep working. So we got subtract 8 on this side, subtract 8 on that side. That leaves us the 5x is equal to 10. This is all stuff that you should know how to do, guys. I don't even know why I'm working this out. So 5 divided by 5 divided by 5, x is equal to 2. And that is done. So key points. must have the same base. If it already has it, cross it out, set the exponents equal to each other, and solve for x. If it doesn't, looking at number 10 here, you have a base of 9, a base of 3, take the bigger base, divide by the smaller base. In this case, we got a 3, but if your answer is bigger than either one of the bases, you got to divide again in order to get something that's equal to one of the bases or less, like we did in this case. So 8 divided by 4 is 2. Well, that changed both of our bases. Once you change your base, you got to figure out how many times you have to multiply that base by itself to get back to the original base. Put that up into your exponent. So in this case, 2 times 2 is 4, so that's 2 2's. Put everything else that was already up there in the exponent inside the parentheses and distribute as necessary. Looking at number 12, if you have a number that's on the bottom of a fraction that you have to bring out, when you bring it out, it's going to have a negative exponent. It might not always be 1, because if this was a 16 down here, you'd have to bring it down. 16 divided by 4 out here, that would have given you 4, and then you would have had to figure out how many times you multiply 4 back to get 16, and so that would have been a 4 to the negative 2 power. Okay, so be careful with that. Let's move on to the back. Okay, so now we're at characteristics of functions. We're talking about exponential functions. It's given you here, right here. A multiplied by b, x minus h plus k. That's a lot. All right. So let me just break it down a little simpler for you. All right. So we're talking about an asymptote here. So notice we have a number with an exponent and then something after the exponent, but not up there with the exponent. Well, the number that's after the exponent is going to always be your asymptote. All right, so let's go ahead and write that in. Y is equal to -2. And so since we have our asymptote, let's go ahead and do our dotted line in here at -2. And because they've provided us with the function, which is this entire thing in green, in order to find 5 good points, like it's telling us here over in the directions, we have to punch this whole part in the calculator under edit function and then go in and look for 5 clean points to help yourself make the graph. And then I'm just going to do a rough graph here. In this case, you were like somewhere up in here, there, right there, and then it goes right there. Okay, so remember, you're never going to go below or above the asymptote. And there's your graph. So it's always going to go increasingly closer to the line, but never touch the asymptote. And so now we can do our domain in range. So we have, let's go with red. Negative infinity. Furthest left is going to go negative infinity. What am I doing? Comma. Furthest right is positive infinity. If we look at our range, it's never going to go below the asymptote, right? So the furthest to the bottom is going to be -2, right? Because it's our asymptote. It's not a bracket because it's never going to touch it. So that's a parenthesis. And then comma, the furthest that is going to go to the top, it's going to go on forever because that's an arrow right there. And so it's going to go on for infinity. So -2 to to infinity. So to recap, this number after the exponent is always your asymptote. Find that and go ahead and put your dotted line there. So you have something to start with. Take this entire function right there, type it in the table of your calculator, find 5 good points. In this case, we found these points. And then you know you're never going to go below this, so start there and start curving up to write your graph. Once you have a graph, hopefully it'll be easy for you to do domain and range. Domain is your furthest left and your furthest right. Range is your furthest to the bottom and then your furthest to the top. I guess one more thing I could note is, follow my pointer here, if this had been a negative out here, well, that would be a transformation. And we talked about that a little bit in class. Whereas the parent function of an exponential graph, it's always going to take this shape right here, unless something acts upon it, right? Actually, it would have been up here more. The asymptote would have been at 0. But when it's negative, it reflects over, and so your shape would have taken, this would have been a roof. The asymptote would have been a roof instead of a floor. And so the curve would have started here, and it would have gone down. That's information that you may need for the test. Now, let's go ahead and look down at number 14. So we're looking at exponential models. This says here that it gives the starting value. Well, your starting value is A. Let me rewrite this kind of how we had it in the class. Well, y is equal to A, B to the x. Okay, and so remember we told you inside the parentheses is like your B is kind of like your common ratio, and then A is your starting amount. Okay, and so we also compared it to geometric sequences. And so we have the y value here, how we find the B, or kind of like R, the common ratio. You take any output, or y, and you divide by the previous term. And so let's write that down for you. So 8 divided by, oops, why not write it 2? 8 divided by 2 is equal to 4. And then, I mean, you could use 32. So 32 divided by 8 is also 4. So we know B is going to be 4. And so let's go ahead and fill that in. 4, we know it's going to be to the x power because it's exponential. And then A, we determined, is our starting, A is our starting value. And so if we look here at our starting number, that is a 2. So, boom, we have our equation. 2 times 4 to the x power. So I will say that again. So I have a bunch of emails popping up on my screen right here. All right, so we got 14 saying write an equation for the chart. They're giving us A times B to the x power. That's what an exponential equation looks like. B is like our R on sequences, so we find that by taking any term, or y, divided by the previous term. 8 divided by 2 is 4. That goes in for B. A is our starting value, which is 2. And again, with the word problems. So it's telling us if the table represents a bee population and a bee house only holds 10,000 bees, how many days will it be before you need another house? So how many days is it going to take to go past 10,000 bees, right? And so how do we do that? We're going to do exactly what we did on the problem earlier. We're going to go into our table. We're going to edit function. We're going to type in 2 times 4 to the x power, and then we're going to go down on the table until we find that y goes above 10,000. When we find that, we look at our x value, and that's going to tell us the number of days. So at 7 days is when you're going to need another house, because at 7 days it's 3,200. It's forecasted to have 32,768 bees. So the answer would be 7 days. Again, punch it into your table, go down until y goes over 10,000, and that x is going to tell you the number of days. Moving along to number 15. All right, so we're reading. The temperature in Georgia has been crazy. Today was a high of 80, and every hour the temperature was 80% of the previous amount. And so what was the temperature that we started with? Well, we started with the high of 80. That's our starting amount. And it's saying that every hour the temperature was going to be 80% of the previous. Remember, let's grab my pointer. I'm going here. I'm going to write there. In order to write that as a decimal, percentage as a decimal, you got to slide it over twice. So that's going to give us a 0.80. Or you can do what I told you in the calculator, which is type 80, and then hit second, the divide key. That's going to put the percent sign on there, and then enter that in, and then it's going to show you what to write. Right? And then to the x power. So now it wants to know what the temperature will be 5 hours later. And so now we are plugging in a 5 for x. So 80 multiplied by 0.85 is equal to 26.21 degrees. All done with that. So let's move along to the last set here, 16 through 19. Oh, you guys better watch this video too, because this is time right here, folks. So 16, we're talking about growth and decay. And so here's growth, 1 plus R, and decay is 1 minus R. And so if you're looking at this with numbers on it, if the stuff inside the parenthesis is 1 or greater than 1, then that's going to be a growth. If it is less than 1, then it's going to be a decay. So again, growth greater than 1 inside the parentheses, decay is less than 1. Also, what's inside the parentheses is what you're keeping, is what you will be keeping. And you guys should remember we discussed that in class. And then, of course, the last thing is P is going to be what you started with. And so now we read. It says the population for Powder Springs in the year 2000 was 25,000. Since then, the population has grown at a rate of 3.2% each year. So this is telling you, by saying grown, that this is going to be growth. And so here's our growth formula right there. It's telling us to write an equation to represent the population of Powder Springs since 2000. Okay, so that's easy. It's telling us in 2000, what did we start with? We started with 25,000. It's telling us we're growing at a rate of 3.2% each year. And so where are we going to write it? We're going to write it just in the middle here. And so we have y is equal to our initial amount, which is 25,000. Inside our parentheses, we'll just write the parentheses for now. It's going to be to the x power. We're doing 1 plus r, right? So our rate, which is 3.2%, remember we have to slide the decimal over twice, once, twice, fill that in with a 0. Decimal goes there, so we know we're going to have 0.032, but we need our plus 1 in front of it, so our 1 plus in front of it, so 1 plus that is equal to 1.032, and that's what's going to go inside our parentheses, 1.032. So to talk that back through, we started with the initial amount of 25,000. That's what we plugged in for P, which is our initial amount. We know we're going to have a growth rate of 3.2%. We slid that decimal over 2 times, which gave us 0.032. Our growth rate is saying 1 plus the rate, so 1 plus 0.032 is equal to 1.032. We plug that in, and we have our equation. Now that we have that, we can answer the next part. According to the equation, what will the population be in the year 2016? We cannot plug in 2016 for X, guys, because that's 2016 years. We want the difference between 2000 and 2016. So that's 2016 minus 2000 is equal to 16. So that's what we will be plugging in for X. So Y is equal to 25,000 multiplied by 1.032 to the 16th power, and that's going to be equal to 41,382.35. But you cannot have 0.35 people, and so you just go ahead and put what's in front of the decimal, since we're dealing in people here. So the final answer here is 41,382 people. Okay, so let's move on to number 17. We got to kick it into gear here because we're running out of time. So 17 says, Mr. Gassi is a machinist. He bought some new machinery for about $125,000. He wants to calculate the value of the machinery over the next 10 years for tax purposes. Let's continue to read there. So if the machinery depreciates means drops or goes down at a rate of 15% per year, what's the value of the machinery at the end of 10 years? And so we're talking about going down, so we have to be talking about decay, which means we're going to be using this decay formula. And so that's right. We started with 125,000. So we started with 125,000. We're talking about going down at a rate of 15%, and so we slide our decimal over twice. That leaves us with 0.15, but we know based on our formula over here, we have to have 1 minus the rate, so 1 minus that is equal to, what is it equal to? 0.85. And so it's less than 1 in here, so it makes sense, because if it's more than 1, we don't have a decay. And then we raise that to the x power. Now they're saying, what is it? What's the value after 10 years? In order to figure that out, we got to plug in 10 for x. So we take our equation, 0.85, since it's a decay, which means if we started with 125,000 and we're talking about it going down, if you do the math and it does not go down, ladies and gentlemen, that's the problem, because we're talking about decay. Once you punch all of that in the calculator, you should get 24609 30. And that's a dollar sign. That's how much money we should be looking at after 10 years. So $24,609.30. Moving down to number 18, we're talking about compound interest. This is going to be provided for you. You just have to know when to use it. Guys, we're talking about compound interest, and this is talking about in here compounded annually. Well, you might want to use the compound interest formula, right? I'm just saying. Okay, so how do we do that? Well, we know P is still the initial amount. We still have basically everything the same. The only thing that we're adding into the formula is N, and that's according to how much it's compounded or how often it's compounded. In this case, it's saying annually. If you use your scale over here, annually is 1, biannually is 2, quarterly 4, monthly, and so on. Okay, so that's telling us exactly what we're going to put in for N. And then your time is still just going based on your time. So in this one, it's saying 8 years. So let's go ahead and write out our equation. So 20,000 is invested. So we're starting with 20,000. Right? And then it's saying at a rate of 3%. And so we have, you know what, let's just go ahead and write this entire thing out. Well, no. So 3%. So you slide the decimal over twice. That's going to give you 0.03. And so, yeah, actually I will write it out. So that's going to give you 1, again, referencing our formula right here, 1 plus our rate, which is 0.03 over how often. So N is how often it's compounded. So in this case, it says compounded annually. And so in this case, we know we're going to put a 1. Then we close the parentheses. 1 there, multiplied by the time, which is 8 years. So as you see, we could have just put 8 out there because 8 times 1 is 8. And really I'm getting ahead of myself. I'm answering the second part of it before I even get to it, because this probably should be just T. So 1T. So now below it's asking you how much money will there be in the account after 8 years. That's when we start plugging in the 8 for T. So I'm going to go ahead. I want to be lazy and just erase that T again and put 8 to save myself the trouble. So, do I want to do that? Yeah, well, guys, you know the drill. Plug in 8 there. And so if we erase that out of there now, that becomes 1 times 8. Plug that in your calculator, and that's going to give you $25,335.40 after 8 years. So, recap. We have the initial amount, which is P. We have 1, which is part of the formula. The rate, it's telling us, is 3%. We have to convert that into a decimal, so that's 0.03 over the fraction of N. What does N represent? How often it's compounded. In this case, it tells us it's annually, which means 1. Okay, and then N, we already know what N is. It's annually, so we put 1. And then down here, it's asking how long. 8 years is time. T is for time. Punch that in your calculator. Boom. After 8 years, you're going to have about over $25,000. And then looking at number 19, geez, do we even need to do that? Yeah, you know what? We've come this far. Might as well. So 27,000 is invested. It's our starting amount. It's telling us that it's invested at a rate of 3.75%. If you slide the decimal over twice, like we know we're supposed to, you end up having a 0 there. So that is 1 plus 0.0375 over, it's saying compounded quarterly. We need to know how often it's compounded to fill in N. We go down here, quarterly is 4 times. And so we place 4 there, and then another 4 there, and then a T. Okay. Now it's asking you to plug in a 3, because it's asking how much money will there be after 3 years. Plug all this in your calculator with a 3 in for T, and you should get 30,199.12. All right, so I don't know how long this video is yet, but it's got to be pretty long. You do not have to listen to the whole thing. As I always say, if you just have some particular spots, and I'm saying this at the end of the video, so this doesn't really matter. I probably should have said this at the beginning. But in the future, you can always just watch the section that you feel like you're struggling with. As we go back for finals and whatever, you're going to need to study this stuff anyway. So when you're going back and watching videos, pause, rewind, watch again, and learn. Ladies and gentlemen, I'm out.